So in this platform, actually, we are going to consider the part of our algebraic graphs, which is the continuation from what we had. Remember, managed to work with other algebraic graphs, how to sketch typical functions, talk of a straight line, talk of a circle, a half circle, an ellipse, a parabola. So make sure that you watch the previous classes so that you just get rid of the concept, because we are going to have a continuation from that working with the cubic function. So we need to consider the format as usual. Each and every function or each and every graph is going to have a function that it operates under. Just like a parabola, we are given y is equal to ax squared plus bx plus c. So you actually wonder what is the difference that we are going to have between a parabola and the cubic function. So a parabola, that's the quadratic having the highest exponent there. So it's on the exponent. A parabola, the highest exponent is 2, or the highest power is 2. Okay, so you're going to consider the highest power is 2. So that is the concept there. On a cubic function, the highest power that you're going to have is going to be a 3. So the highest power must be a 3. The highest power is 3. So that is what we refer to as a cubic, a quadratic, which is a parabola. The highest exponent, the power there, is going to be a 2. But for a cubic, it's going to be a 3. So it can also be given as just maybe y is equal to x cubed. Do not like all this part must be there. No. What matters is the exponent that is there. So it's a cubic function. It can be given as y is equal to x cubed minus 3. Still, it's a cubic function. The highest exponent there is a 3. So it's not about having everything to see these terms, the power of x squared, the power of x, and the power of the constant. No, it's not about that. It can be given like that. Y is equal to x cubed minus x. It's a cubic function. So it's not about seeing everything there. So, okay, given the cubic function, let's say we are given an example that we need to sketch the graph of. We just need to sketch the graph of y is equal to x cubed minus x squared minus 4x plus f4. Let's say that's our cubic function. All right. So you are going to see or notice that a cubic function, as you are to sketch, we are going to expect these things before we talk about the sketching there. This is what we are going to expect. One, the shape from the coefficient of this a, the coefficient of x cubed, which is our a. Remember the coefficient of x cubed, which is our a. Provided that a is greater than a 0. So a is going to determine the shape. So a determines the shape. Let me just write here. A determines the shape. So we saw this also on a parabola. We saw that a there was determining the shape. When a is a positive, we're going to have a smiley shape. When a is a negative, we're going to have a set shape. That was the part of our a. What about a cubic function? How are we going to have this? What is the shape that you're going to expect if this a is given or to be taken as a positive? This is the type of function that is going to increase in terms of its values. So we're going to have an increase in terms of its values like this. The function is going to be increasing, starting from the negative, increasing up to endless values. This is on a condition where a is greater than a 0. That is the shape that you're going to have, which means we're talking about the positive values in that case. So considering usually we expect something of this nature. So this is usually what you're going to expect. Not to say always it's going to be like this, but usually you expect to have something of this nature where our function is going to pass through the three values, the 3 points in the x-axis. This is the most part of a cubic function. You're supposed to have 3 solutions, but there are some functions that will be having 3 solutions, but another solution will be repeating. On that case, you are not going to have a condition like this. But in this case, we are going to have 3 solutions. Remember, these are x-intercepts. So let's say there we've got x1, we've got x2, and we've got x3. These are solutions. X1, right? So the x1, the x2, and x3, these are solutions. So whenever we talk of the solutions, we are referring to the what? To the roots. So these are the roots or the solutions, which means we are talking about the x-intercepts. And what is the condition about the x-intercepts? If you understand from the introduction that we had, it's a condition where y is equal to 0 along the x-axis. Remember, y is equal to a 0. So in that condition, to determine these, y is supposed to be a 0. That is the condition. So as long as you've got this concept, meaning to say you're going to consider that. Then also we are going to talk of the y-intercept. That is the part where the graph cuts the y-axis. Remember that will be our y-intercept. And what is the condition for the y-intercept? X is supposed to be equal to a 0. So with this part, considering our functions, considering working with the normal way of just sketching, just to sketch, this will be fine. But we are going to see this later on under the derivatives, where we are going to be referring now to these turning points also. So under derivatives, they will need also for you to determine these turning points from the derivative concept, that at any turning point, remember, the first derivative is equal to 0. But for now, we are not considering that. We are just considering this part of the sketching. So that is the concept. So we are going to talk about that later on under calculus, working with differentiation. How do you actually sketch that type of a function, working with the derivatives or working with the differentiation. So from what we had, let us consider this. All right. The other part we are going to have, all right, on the shape there, we are going to expect if this a is less than a 0 like that. So we are going to have our function decreasing. So it's going to start with positive, then it will be decreasing, like going to the negative. All right. So it's going to be going to the negative. Positive, it's increasing. That is all to the positive. So it's going to be continuous increasing to the positive, something like that. All right. I hope it's going to help. All right. So let's consider this function. We saw that we are going to need the x-intercepts and the y-intercept. So the y-intercept here is the easiest part. Let's just talk about this first before we consider a lot of working there. The y-intercept is on a condition where x is equal to 0, guys, and that will be the value of d, which is the constant, our 4. Guys, by substituting a 0 here, that means we are going to obtain what? A 4. So in place of x, you must have a 0. That is 0 to the exponent of 3, 0 to the exponent of 2, minus 4 times 0 plus a 4. So from your calculator, you are going to obtain a 4. That is the y value when x is equal to 0, which is our x, which is our y-intercept in that case. Now, considering that when this y is equal to 0, we are now considering the x-intercept. All right, so I want you to see something here. Y is equal to 0 on that case. So meaning to say this whole function that we are given of x cubed minus x squared minus 4x plus a 4 must be equated to this y here being a 0. Guys, just as usual, we had this condition back from our quadratic function or a parabola. You write something like this: x squared plus 5x plus 6 is what is it that you have? It's an equation. This is equal to this. And on an equation, you must solve for x. You must solve for the unknown, which is for x. So that is the same case that we are having. By letting this y to be equal to 0, we are now having this being equal to 0, which is an equation that has to be solved. But take a closer look. What type of an equation is this? So if you consider this properly, you will see that we are back to the factor and remainder theorem. Remember that under our factor and remainder theorem, where you were working with the cubic functions. Remember, you were given a question that you remember on your question number 1, you can be given a question like this: factorize completely x cubed minus x squared minus 4x plus 4, like this. You must expect that's question number 1. Remember that. Just to factorize. Also, you must expect a question like this solve. So we are back to that solving. But as we know that as we deal with the cubic function, so I want you to go back to the cubic function so that you revise, to the factor and remainder theorem, work with the questions, how to factorize cubic functions and solving for that. All right. So in this case, definitely we are going to need to factorize this. So factorizing, remember, we need the first factor. There we are not given a factor like in cases of where you are given x plus 1 is a factor of this or x minus 1 is a factor of this. Find the other factors. No, this is not the case. There you are starting from scratch. So remember, we said we consider the constant, which is 4. What are the factors of 4? So we are going to need the factors products of 4, which are the factors of 4 numbers that you multiply and you get a 4. We have got plus or minus 1, plus or minus 2. Once we have plus or minus 2, we can't use plus or minus 4 because 4 is there. The 2 is there in this 4. So meaning to say, we are just going to consider plus or minus 1, plus or minus 2. What is the case of these numbers? Remember, you must substitute a number that when you substitute into a certain value, if you substitute x plus a, if you substitute x being a into the function and you obtain a 0, it follows that x minus a is a factor. Remember the concept. Same way, if you substitute, maybe it's a negative f of minus a, you obtain a 0. If you substitute a negative number and you obtain a 0, what does it mean? It means, therefore, x minus a. So if you consider x minus a at the end is going to be what? X plus a. So it means that x plus a is a factor. So simply a factor is x minus the number that is here. X minus the number that you substituted to obtain what? A 0. That gives you a factor. So if you substitute a 3 and you obtain a 0, so it means x minus this number is a factor. If you substitute a minus 3 and you obtain a 0, what does it mean? It means x minus this number that you substituted, minus 3, is a factor, meaning to say x plus 3 is a factor. So that is the condition. We are back to that condition that we had before. So that's why I said make sure that you go through your factor and remainder theorem. All right, so let's start with these numbers. So it's a trial and error that we are going to do. It's a trial and error. You substitute. Trying these values, let's start with 1. In place of x, that will be 1 cubed minus 1 squared minus 4 times 1 plus a 4. So this part, you're just going to substitute on your calculator. That is going to be something like, there's going to be minus 4 plus a 4, which is actually going to give us a 0. All right. So if you consider this part, we are obtaining a 0 in this case, 1 minus 1. This is just 1 minus 1 minus 4 plus 4. That's a 0 here, a 0 here. So what is it that we are considering in this case? We substituted a 1 and we obtained a 0 in this case. Let's consider what we're talking about here. If I substitute a and obtain a 0, it means x minus that a is a factor. So therefore, from this, what we substituted, which is 1, which gave us a 0 in this case, we can say, therefore, x minus that number that you substituted, which is 1. x minus 1 is a factor. So we are now talking of a factor. What's the purpose of a factor? The purpose of a factor is that we use it to divide. Long division. So this is the case, guys. If you are someone that is not going to work with the long division, guys, you can try these numbers here. I want you to see something. Maybe you used -1. Okay, let's try -1 and see. I want you to see something. F of -1. So you're going to try -1 in place of x. That will be -1 cubed minus 1 squared minus 4 times -1 plus a 4. All right, let me just try and show my calculator here so that at least we can be together, because sometimes you can actually do these factors, all of them, then you're just done. Guys, I want you to see something. All right, this is it here. You can actually, if you have time, like you can try -1. So that is a -1. So I'm just going to open a bracket here. -1 to the exponent of 3. Then we've got negative, open a bracket, -1 to the exponent of 2 minus a 4 into a -1 like this plus a 4. So this one, it is giving us a 6. We are obtaining a 6. So meaning to say, we do not have a factor. We are supposed to obtain what? A 0. So we move on to the other number. Remember, we have got what? Plus or minus 2. So there is 2. So let's try f of 2. So f of 2, in place of this, you're just going to substitute a 2. So that's a 2 here. All right. That's another 2 here. All right. That's a 2 here. You just substitute a 2. So as you can see, f of 2 is giving us what? A 0. You're obtaining a 0 there. F of 2 is equal to 0. So what does it mean if f of 2 is equal? Just like the previous case, if f of a is equal to, so therefore, we have x minus the number is a factor. So you could have worked with this number as your factor. Okay, let's do the same thing. Let's substitute this time -2. Remember, there's a -2 there. So you're going to have minus. All right, minus. All right. So if you have time, you can do this. Minus, that's a 0 again. So as we can see, f of -2 is giving us, as if we substitute -2 here, we are obtaining a 0. So therefore, we substitute there. Therefore, x minus -2 is a factor. Minus, that's what? That's a +2. So meaning to say, we are simply talking of x plus 2 is a factor. All right. Guys, I want you to see something. If you can do this, you substituted all these values that you were substituted and you obtained a 0. Guys, this is a cubic function. And what is it that you know on a cubic function? It must have 3 roots, 3 solutions, 3 values of x when you solve it. Remember, what we need here is to find the x values. As we can see, the first one, x minus 1 is a factor. This one, these 3, we have got factors, but these are not x values. So what are the x values? The x values are the ones, remember, we are saying y is equal to 0. So it's on a condition when these factors, x minus 1, x minus 2, and x plus 2 are equal to 0. So we can obtain the x values, of which, if you understand from the concept that when you are substituting, f of 1 is equal to, that is the value of x that we need there. So x is equal to 1. But if you do not understand that, guys, okay, I don't want to confuse you. Let me leave it like that. Take your factors, equate them to 0. So that's it. So each bracket is equal to 0. So x is equal to 1. Transpose -1 to the other side, it becomes a +1. Or x is equal to what? -2 to the other side, it becomes a +2. Or x is equal to what? The 2 to the other side, it becomes a -2. These are the x values, the x intercepts of our cubic function. So if you know that concept, guys, of substituting, you substitute all your values and obtain a 0. Where there is a 0, that's a factor. Where there's a 0, that's a factor. You have the factor concept. All right. So that is another part to consider. But in this case, we want to consider using the major way that most of us are used to, textbooks, they explain that way, which is the part of the long division from our factor and remainder theorem. So using the long division concept, you are going to take only one of the factors. You're going to try the values where you obtain a 0, then that will be a factor from there. You have your a factor. Like what we did here, we substituted a 1 and obtained a 0. So therefore, x minus 1 is a factor. Once you obtain a factor, you stop from there. If you are using loading, there's no need now for you to try other factors. You see that this is a factor here. One factor is enough. You stop from there. So what are you going to do with that factor? Using the long division, you are going to divide the factor into the function that we are given, x minus 1, into our function, which is x cubed minus x squared minus 4x plus 4. So that's another way working with the long division. From one factor that you obtained, you divide into the original function. So what is it that we know? We know that if you divide 6 by its factor, which is 2, we are supposed to obtain an answer which is also a factor of 6. This 3 here is a factor of 6. The 2 is a factor of 6. And also, we do not have a remainder. If you divide a number by its factor, you are not going to have a remainder. And also, the product of these two numbers, 2 times 6, 2 times this 3, is supposed to give us a 6. So meaning to say, if I divide this factor into this, whatever that I'm going to obtain here is going to be also a factor. There is no way. You divide 6 and 2, you obtain a 3. 3 is also a factor of 6. And we are not going to have a remainder, meaning to say our remainder must be a 0. There is no remainder there. There is no remainder. Remainder is 0. So if you obtain a remainder when you are dividing with a factor like this, and you obtain a remainder, which is 2, whatever that you obtain, guys, redo your long division. That answer is wrong. Do not continue. You are not supposed to have a remainder when it is a factor. Okay, guys, do not quote me wrong. When it is a factor, when this part that you're dividing with is a factor, the remainder is supposed to be a 0. That is, there is no remainder there. All right, so let's divide. Guys, as usual, your long division, we talked about this, the first term to the first term. So you divide x cubed divided by x. So x into x cubed, that's x squared. So you're going to have x squared, and whatever that you obtain here multiplies back everything that you are seeing there. So it's x squared into x minus 1. X and x squared and x, which is x cubed. X squared and minus 1, that's minus x squared. So you multiply back everything. You divide, then you multiply back. Then what is it that you're going to do? Subtract. Okay, so you're going to divide, you multiply back, you subtract. So let's subtract and see what you're going to have in this case. X cubed minus x cubed, that's a 0. Minus x squared minus x squared. So it's like this, minus x squared minus x squared. So that'll be a plus. So that's minus x squared plus x squared, which is just a 0 there. Minus 1 plus 1. So that's a 0. You're not having anything here. There is nothing that is remaining. So what are we going to do? We are going to drop the remaining part after subtracting. Drop the remaining terms. So the remaining terms, that is, we're going to drop this negative 4x. So we're going to have negative 4x. We drop this 4. That's a plus 4. So that's negative 4x, and that's a plus 4. Then we divide again. We are back, we repeat. Whatever that we are doing there, we're going to repeat. Divide first term to the first term. So that is negative 4x to the first term, which is x. This and this will cancel. That's, we've got what? A negative 4. And what is it that you do after dividing? You must multiply back whatever that you're given to everything. So the minus 4 will multiply back everything that you're given, which is the minus 4 into x minus 1. Minus 4 and x, that is going to be minus 4x. -4, and -1. That's a +4. So you're multiplying back the -4 to x minus 4x -4 to 1 to -1. That's a +4. Guys, these two terms are the same. Whatever that we are seeing on top and whatever that we are seeing here is the same. So by subtracting, that's a 0. Guys, if you subtract -2 from minus like this, you subtract this -2 from a minus, you're subtracting the same number. That's a 0. Just like 2 minus 2. Just like 3 minus 3. So the moment you subtract a -4 from a -4, that's a 0 there. Okay? That's simply minus, which is what? A plus in this case. That will be a 0. So the same thing, -4x minus -4x, that will be a plus. And that will be -4x plus 4x, which is a 0. So that's a 0 there. There's nothing that you obtain. And the 4 minus 4 that we are having here, that's a 0 also. Okay? So meaning to say, we are not having the remainder. Like I said, when you divide by a factor, the remainder is supposed to be a 0. And remember what I said, whatever that you're going to obtain here will be also a factor. There is no way, guys, we saw this. 6 divided by 2, which is factor, we obtain 3, which is also a factor of what? Of 6. So 2 and 3 are factors of 6. These are factors of 6. So meaning to say 2 times 3 is equal to 6, or 6 is equal to 2 times 3. So that is the concept there. There is no way. So if 6, this one, is equal to 2 times 3, it means the whole function that we had representing our 6, which is the whole function that we had before, this f of x. The whole function, the x cubed minus x squared minus 4x plus 4 is equal to the product of what was divided in the other term, which is this part and this part. So you're going to multiply. So it's the product of x minus 1 into x squared minus 4. So if these and these are the same, we can take advantage of what is on the right-hand side, because those are factors that are simplified, and we can factorize further from there. So in most cases, you can actually have a normal quadratic x squared plus 5x plus 6. You factorize that. But in this case, we've got x squared minus 4. What is this? A difference of 2 squares. Remember, a squared minus b squared, it's a minus b into a plus b. So that's a difference of 2 squares that you're having. Therefore, here can be written as a 2 squared. So meaning to say we've got 2 brackets there, x minus 1 into the bracket of x minus 2 and another bracket x plus 2. Okay, are these not the same factors that we had previously when we were working each term by, when we're dividing by each number? These are the same and exactly the factors that we had. But we are not looking for the factors, guys. These are factors, not solutions. So we need the solutions now, the roots. So what will be the roots? The condition of the roots, just like the previous case, guys, what we did for the roots, which is the x values or the x-intercept or the solutions, y is supposed to be equal to 0. And y is the function, this one that we are seeing when we are presenting this x cubed, whatever, that is our y, this one. So y is supposed to be equal to 0 for us to obtain what? To obtain the roots, y is supposed to be equal to a 0. So it means this whole part representing our y is equal to 0. X minus 1 into x minus 2 into x plus 2 must be equal to a 0. So just like the previous case, guys, it means this bracket is equal to 0. This bracket is also equal. This bracket is also equal to 0. So we can just solve by sight, by just looking into, because we understand that minus 1 transfers there. It becomes a positive 1. The same with the minus 2 becomes a positive 2. The same with the plus 2, there it changes its sign to a negative 2. So these are the x values or the roots of our graph, which are the same roots. These are the same root that we had from the first method of working factor by factor, factor by factor, factor by factor to the last one, up to when you obtain 3 factors, because it's a cubic function. So this is it. You have got your cubic function in this case. This is what we have. We have, the solutions or the roots of our function. And also we have got the y-intercept. Like I said, this is not a method that we are applying the derivatives. No. So we are going to use the function concept just like this, the y-intercept and the x-intercept. This is enough. And also the shape that you are supposed to have at the end. So this is it, guys. So we're going to take our roots. Remember, I'm just going to write our y-intercept here so that we can see it properly. Remember, we had our y-intercept here. Where is it, guys? Here, y is equal to 4. All right, so y is equal to 4. So I'm just going to take these. These two are enough. So the roots and the y-intercept. So remember, our y-intercept was at a condition where x is equal to 0 and y was equal to 4. And also considering the function that we are having in this case, we are going to have the shape of a positive, because that is, remember, that is given as x cubed minus x squared minus 4x plus 4. So the shape, we said, is going to be forever positive, going upwards like that. So this is it. So this is a sketch, guys. Going to have something like this, your x and your y. That's a 0 here. So just going to consider 4. So let's just say we've got a 1, 2, 3, minus 1, minus 2, minus 3. Then we have got minus 1, minus 2, 1, 2, 3, 4, and so on. All right, so just going to have 4, and so on and so on. All right, so this is what we going to have. The intercepts, that is at minus 2, we've got a negative there. So you're going to mark minus 2, 1, that is 1. A 2, that's a 2 here. All right. So what we know is that in between, like, let's say our graph is like this. In between the x-intercepts, this one, it's a turning point. So as our graph is to meet this point, let me just try and reduce a little bit so that it does not stretch me further. 1, 2, 3, 4, 5, like that. All right. So it means that as our function is going to pass through the point 4 in the y-axis, it must be considered to a certain turning point. It must be considered to a certain turning point, then goes back to the y-intercept. In between these 2 points here, there's also a turning point, 1 and 2. There's also a turning point. So you must supposed to consider that. But in this case, with the method that we are using, we cannot tell our turning points, guys. All right, so let me just try doing this way. So it must be to the y-intercept, then to the turning point. So let's just say like this. All right, passing through this point. So there we're going to have something, a turning point, which in this case, we're just going to leave it like that. Then here also, between these x values, there's also a turning point. So you must just show that here, there's also a turning point, and it goes up again. All right. So this is what we are going to expect. So in between here, there must be a turning point. In between here, there must be a turning point, which is the part that I said we are going to consider with the derivatives later on, which is the part of calculus. But for now, what they want you to do when it is just a normal algebraic is to understand x-intercepts, the y-intercept. So as you can see, the major part there is on how are you going to obtain the x-intercepts. So like I said, do revise your factor and remainder theorem. So I think with this information, you can be able to answer any questions that you are given on the cubic function. So we're also going to come back again with a typical exam question so that we see how are we going to apply this with also other methods of the derivatives, where now the turning points are to be included. But for now, guys, that's it from Amazon African Motives. Till we meet again.